Alright everyone, welcome to this video where we're going to learn how to name ionic compounds and come up with their formulas. This particular concept, kind of like moles, is something that we're going to use for the entire year, so it's really important that you get this one down. So I would spend a little bit extra time making sure that you go through all the practice problems and you go through the guided practice problems so that you can really understand. Once you get it down though, it's really not that bad. So let's go ahead and talk about binary ionic compounds. Well, binary means two, and so binary ionic compounds come from two atoms. And so one atom is going to be a metal and one is a non-metal. And for those of you who need a little bit of reminder, here's the staircase. This is a metal. These are metals. These are non-metals. And so a metal and a non-metal will make a ionic compound. So one of these and one of these, ionic compound. All right. Monatomic ions, okay, so that's one atom that are ions, are charged atoms that form from a single atom. And so we've talked about this. So we've talked about how atoms will lose or gain electrons and they'll gain a charge. And so if we have one atom that's doing this, it's a monatomic ion. Monatomic cations, remember cats have paws, are named simply by the elements named followed by the word ion. So for example, I'm going to let you know, just a quick reminder, metals make cations. And so for example, copper will make a 2+ or a 1+, and we'll talk about that later, but we call it copper ion. Zinc, when it makes its ion, we call it a zinc ion. And so whenever these make a charged ion, we just call it by its name followed by the word ion. Now lithium has one valence electron, and what it will do is we'll lose that one valence electron and become a 1+. And so these charges that are on the screen here, these are something that we learned last unit, and so we're going to be using those a lot. So again, lithium loses a negative electron, becomes 1 positive. All right, beryllium has 2 valence electrons. It will lose those 2 valence electrons and become a 2 positive. And when it becomes a 2 positive, we call it beryllium ion. The lithium we call lithium ion, so very easy. Just add the word ion when it becomes an ion. Now, monatomic anions are a little bit different, and they're named by changing the ending of the element's name to "ide." So the anion, which is the negative ion, we just change the ending to "ide." And so nitrogen has 5 valence electrons. It will gain 3 electrons, and so when it gains those 3 negative electrons, it becomes a 3 negative. And there it is, 3 negative electrons, 3 negative. And so 1, 2, and 3, and it gains those 3, becomes a 3 negative. Now instead of calling it nitrogen, we call it nitride. And so again, when we have negative anions, we change the ending to "ide." All right, chlorine has 7 valence electrons. It will gain 1 negative electron and become a 1 negative charge. Notice how hydrogen's on both sides. I just want to point that out real quick because hydrogen can either lose or gain an electron. It can either become 1+ or 1-. And so when hydrogen becomes a 1-, we call it a hydride ion. All right. So we're going to learn about bonding next unit, but let's go ahead and we're going to have a little bit of a preview. This is essentially what happens. Beryllium wants to lose 2 valence electrons, and when it loses those 2 valence electrons, those electrons have to go somewhere. Now fluorine wants to gain 1 negative electron. When it gains 1 negative electron, it's going to be satisfied and all that. So notice how for beryllium to lose its 2 valence electrons, there needs to be 2 fluorines because each one will gain electrons. So there we go, we have 1 and 2. And so notice how for beryllium to lose 2 valence electrons, it needs to have 2 fluorines around it to gain those electrons. Now the fluorine and the beryllium, so the beryllium becomes a 2+ and the fluorine becomes a 1-. And what I want you to notice is, what is the overall charge of everything? Well, the fluorines each are 1 negative, so that's a total of 2 negative, and then the beryllium is 2 positive. So the overall charge of everything is 0. And that's actually really important to note. When ionic compounds form, when atoms come together to form ionic compounds, their overall charge will always be 0. And so this is going to really help us in a moment here. All right, So when writing binary ionic compounds, so that's ionic compounds that have two atoms in it, you will always write the cation first, so the positive ion or the metal, and the anion second, so the nonmetal. So you always write the metal first and then the nonmetal. So here's an example. So here's NaCl, we have the sodium first and the chlorine second, except for it's not chlorine anymore, it's chloride. So first thing you want to do is write the name of the cation, that's the cation, the sodium is the cation. Then you want to write the name of the nonmetal, which is the chlorine, except for the chlorine you change to "ide," so it's chloride. So that's sodium chloride. And so that's how you write it. It's really straightforward. So sodium chloride. All right, this one. Go ahead and pause the video, give it a shot. See if you can name this. Very straightforward. All right, first, lithium. Okay. Second, nitrogen, except we change the ending to "ide," lithium nitride. So that is lithium nitride. Very nice. Okay, now compounds containing polyatomic ions, which we're going to talk about what a polyatomic ion is in a moment, are named in the same manner, and the formulas containing polyatomic ions are written in the same manner as binary ionic compounds. So let's go ahead and talk about what polyatomic ions are. If you take a look here, this is a list of polyatomic ions, and if you look in your booklet, if you open it up, you'll actually see a list of polyatomic ions right when you open it up right here. So these are polyatomic ions, and you will use these for writing formulas. And so notice what they are. So first off, it's a group of atoms that have a charge. And so it's not just one atom with a charge, it's a group of atoms with a charge. And so these are covalently bonded atoms, which we will learn next unit more about covalent bonds. But they're bonded in a different way. So they're covalently bonded, yet the whole thing has lost or gained charges. And so, for example, perbromate, the very first one in that first column, perbromate is BrO4, so that means there's a bromine and 4 oxygens, and then notice how it has a 1 negative charge. So the whole thing is a 1 negative. Notice at the very bottom we have hypoiodite. That's IO 1 negative, and so that's IO and then a 1 negative charge. Nitrate, the top of the second column there, is 1 nitrogen, 3 oxygens, and the whole thing has a 1 negative charge. And so go ahead and take a moment to look through this. Notice the third column, the very top is sulfite, that's SO3 2 negative. And so some of them have 2 negative charges. Some of them have 3 negative, some have 1 negative. And then we have ammonium. Ammonium is NH4 1 positive. So again, a polyatomic ion is a positively or negatively charged group of atoms that are covalently bonded together. All right, so let's go ahead and talk about how we name this. And so whenever you have a compound that pretty much has more than 2 atoms, it's going to have a polyatomic ion. So if it has more than 2 atoms, more than 2 types of atoms, it'll have a polyatomic ion in there. So notice here how MnO4 is actually on your list. If you look on your list in your booklet, MnO4 is on your list, and that is permanganate. And the way you name this is you just name the first element there, so potassium, okay? And then the second part is just permanganate. There's no changing the ending or anything. You just name it what it is in your booklet. And so it's very straightforward. So it's potassium permanganate. All right. This one, again, this has more than 2 types of atoms. So that means there's a polyatomic ion in there. The polyatomic ion happens to be SO4. And so what you do is you name the first one, which is calcium. Okay. And then this SO4, if you look in your booklet, is sulfate. And there it is. All right. All right, now hydrated ionic compounds they're called hydrates. They have a specific number of water molecules. And so within the ionic compound itself, in the structure itself, there's a certain number of water molecules. Now, in the solid, these water molecules are part of the structure itself. The way that we write it is we'll write the formula, and then we write a raised dot, which is kind of like a multiplication symbol, and then we write the number of waters after it. Also, the number of water molecules are indicated using a Greek prefix, and so if we have we will have a we're going to learn about prefixes for covalent compounds a lot more, but essentially if there's 5 waters, we will say there's heptahydrate. If there's 6 waters, it's hexahydrate. And so we're going to learn those prefixes more for covalent compounds. Often the hydrate and the anhydrous, which anhydrous means without water, they'll have different colors. And so they'll have distinct colors to them. So here are the different prefixes. So one is mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And so this list is actually on your next set of notes as well. And so you don't need to write it down or anything, but you will have to have these prefixes memorized, and you'll have to have them solid in your mind. So let's go ahead and take a look here. So notice how this is a hydrate because we've got the raised dot and then the 7 water molecules. And so the first thing we do is we name the first part normal. So the first part is magnesium. The second part is sulfate, so it's magnesium sulfate. And then 7 is heptahydrate. So it's magnesium sulfate heptahydrate. And so there we go. Now, transition metals, which are these right here, so the D block and the F block, but we're going to deal mostly with the D block, they can actually have multiple ions. They can form multiple ions. They have multiple charges. And so, for example, copper can be a 2+ or a 1+. Iron can be a 2+ or a 3+. And then, all of them, there's some of them that can be 7+, and so on. And so there's some of them that have many different charges. And so when we're dealing with transition metals, we will need to use a Roman numeral to indicate the charge. And so here's a list of different ionic transition metals. Notice how they have different charges, and so chromium can be a 2+ or 3+, iron's 2+ or 3+, and so on. And so they have multiple charges. So when we're naming them, we can't just say like iron chloride. We have to say iron 2 chloride or iron 3 chloride because we need to know which charge that iron is. And so, for example, this here is copper chloride, except the copper can have a 2+ or a 1+. Now, this is where we have to sort of think backwards. What charge does the chloride make? So we have to think about what charge does the chloride make. And so chloride's right here, and it makes a 1 negative charge. So chloride makes a 1 negative charge. So if it makes a 1 negative charge, and there's 2 chlorides, what charge must the copper be to balance that 1 negative? So again, it's got to add up to 0. So what charge must the copper be to balance those 2 negative charges? Well, the copper must be a 2 positive. It must be a 2 positive charge to balance the 2 negatives. And so when we're writing this, we have to write copper, but we don't just write copper, we write copper 2, because we need to distinguish that it's a 2 charge and not just a 1 charge. And then we write the chloride. Now, what I will say is there is copper 1. So what would the formula be if it was copper 1 chloride? Well, if you take a look here, chlorine is a 1 charge, as a 1 negative, and if this were a 1 positive, it would be a 1-to-1 ratio, so it would be CuCl. And so what we're going to do is we're going to have a lot of practice of this in the practice problems. And so that's the gist of how you balance the charges. After this notes, there's actually a continuation of the notes, and I want you to read through those notes before watching the guided practice problems. So I want you to read through the rest of these notes that are with this set of notes, where it talks about balancing charges, before you watch the guided practice problem videos, and then when you watch the guided practice problem videos, it'll make a lot more sense. So go ahead and watch that. That's a very crucial part to this. And you have a great day.